Can you solve this coding challenge called shortest word distance? Give an array of strings, word dictionary, and two different strings that already exist in the array, word 1 and word 2, return the shortest distance between these two words in the list. And if you look at this first example here, basically word 1 is code and word 2 is practice, and they want you to find output 3, which is the shortest distance between practice and coding in this dictionary. The constraints are below. We're guaranteed to at least have 2 words in this word dictionary. The word length is guaranteed to at least have 1 word, but never more than 10. Always will be English letters in the words. And both words will always be in the dictionary. That's pretty important constraint. And word 1 is never equal to word 2. That's pretty important in constraints. In the interview, you may be given these constraints or you may have to ask for them. So how would you do something like this? Well, you basically need to check for word 1 and word 2 in the dictionary. You need to find every instance of each of the words. And every time you do, you need to measure the distance between the words. And since we're looking for the shortest distance, you really just need to look for the last instance of each of the words and what's the distance between them. So let's move over to the code. So here in the code, I have a function called shortest distance, which takes in the word dictionary, the word 1 and the word 2 as the input. The first thing you want to do is create an index for word 1 and an index for word 2 to keep track of the locations of the last or the latest word 1 and word 2 inside the dictionary. Right now, since we haven't found any yet, we're just going to set these both to -1. Then we want to make a variable called min distance to keep track of the minimum distance between the 2 words that we found. At the start of this algorithm, the minimum distance, we can just set it equal to the length of the word dictionary itself, because that's the maximum distance any 2 words can be from each other. Then you want to start looping through the word dictionary. For each word in the word dictionary, you want to check if that word is word 1 or if that word is word 2. If it's word 1, you want to set the word 1 index equal to that index. If it's word 2, you want to set word 2 index to equal to that index. And what this will do will keep track of the indexes of both your words to see if you found them. The last thing you do inside the loop is if you have found, they're not -1, you found an index for 1 and 2, then now you want to calculate the distance between them. So current distance here equals the absolute value of word 1 index minus word 2 index, which gives you the distance between those 2 words. And min distance, we can update min distance, our variable that we started above, by basically taking the minimum of the current distance and min distance. So we only want to hold the value of the minimum distance we found so far between word 1 and word 2. We don't want to disregard anything that's higher. And what this line of code here will do is just always return us the minimum. So we'll only keep track of the minimum in our variable. And after you loop through all the words in the word dictionary, at the end, you'll just return min distance, which will be the minimum distance between these 2 words. Hope that makes sense. What we can do on Leetcode.com is run the test cases to see if our code works. And we see here that we got it accepted for the first dictionary that we're looking at. Got an output of 3. That's what was expected. Case 2, we got the output and input that we expected. Other thing we can talk about is the time and space complexity. Time complexity is based on the number of operations we run with respect to the size of the inputs that we have. Here we have word dictionary, which has a length, which has an amount of words in it. We know we're going to loop through it 1 time. So let's call that n, the length of word dictionary. We know we're doing that many operations with respect to our input. And in word 1 and word 2, the thing we're doing there is checking for equality. So when you check for equality with strings, what's actually happening in the background is it's checking each individual letter to make sure that it's equal before it says that the 2 words are equal. So this is also operation that's with respect to the length of these words. And so let's call the length of these words m. And so we could say here that for every loop we do, we potentially need to check the length of these words as well. And so the time complexity will be big O of n times m, where n is the length of the dictionary and m is the length of the longest word, which in our constraints should be no greater than 10. So we could say m worst case is 10. And then space complexity, since with respect to our input, we didn't use any additional data structures such as arrays or dictionaries or anything in addition to our input. We didn't add anything new. So we can say that we use constant space. Like the amount of space we use with these operations does not change based on the size of our input. It always will basically stay the same. And so that means our space complexity is constant, big O of 1. So I hope that makes sense. Let me know if you have any questions. Let me know if you have any ways to optimize this. Thanks for listening.